IoT technologies. And before going to talk about the latest and emerging technology, I will introduce the very basic introduction and how young students can involve this kind of technology to develop by themselves. And then after we will go to the several healthcare related applications. So last week also I have delivered talk based on IoT technology. So maybe some of you has already heard about the connected vehicles and Internet of Vehicles technology. I have discussed last week. Today I'm going to talk about the IoT technology for e-healthcare services. So how IoT technologies can get support for the healthcare services and healthcare remotely healthcare monitoring application as well. So there I will discuss how we have developed the stack, how we have developed the routing protocols, what kind of applications behind that. So we will discuss more detail about that. So actually this is the project like e-healthcare monitoring applications. This project I'm working last 15 years. So some of result is based on my previous works. Some of we are going to what project we are still working on that. So motivational talk, we will go motivational research opportunities. So that will be helpful for you to where you guys can involve and you can think in future projects as well. So before going to the core topics, let me introduce you about where I am now. So this is the world map, and you guys can see here is the India yellow part, and we are currently working. I'm working in South Korea here, so you guys maybe heard about the South Korea and North Korea. They are the two Korea. So North Korea is this red part and yellow part, very small. It's I think the size of the only one state of the India, small state even though. So we have about 600 kilometers range from one area to another area, you can see. So it's very small country. And we have here, our university is based on the Seoul, the capital city of this Korea. So that is the name is the Seoul. And we have several campuses. So one campus is the center of the Seoul. Another one is the little bit about 50 or 20 kilometers outside from the Seoul city. And another one is the near the airport, international airport. So currently I'm talking it from here, this building. So this is the we called global campus. And our university rank is in the world has 392 now, and in top 10 in the South Korea as well, last several years. So we are doing pretty good in the research work as well as teaching aspects. We have a very big university and 25,000 students are studying in this university. So maybe Korea, most of the students don't know, but you guys know about the brand like Samsung, Hyundai, LG Telecom. So today here I have just cited top 10 brands in South Korea. So maybe you guys know about the Samsung. Everybody heard about this name. Hyundai Motors in India, lots of cars are going on. So now they have another brand, which is the SK Telecom and Kipo. So this you can see SK Hynix is the electronics chip device. This is the telecommunication device. And this is the Sinhang Bank. Kia is recently launched their vehicles car in India. So maybe you guys heard about this name as well. So Kia Motors, just last year, they launched their new vehicles in India, Indian market. So in Korea, we have big market in Kia as well. And another one is the KB Bank and Korea Telecom. This is telecom company. So, and this one is the Samsung CNT. This you can see the 10th position is the Samsung is the construction company. So Samsung is doing a lots of business in international construction, buildings, long buildings and bridges they are making on that. But you can see there is still top 10, the LG company is not involved. So, but LG is also from the Korea. So why I'm showing this, just only reason is that because Korea is very small country, they do not have enough resources. So they are developing technologies. Okay, so they are exporting technologies to other country and importing foods from other country because they cannot grow fruits here because lands are very less and four side is the sea area. So what they do that they develop the technology and exporting all over the world. So especially you guys can see here the telecom companies, a lots of telecom companies which are creating lots of business in Korea as well. So you guys see they are very much influenced about the technologies aspects as well. So now come to the topic where we have to talk today. So today we are talking about the IoT technologies and what is IoT, then history about IoT and motivation of the IoT technologies, current status. So I will go slowly, one or two slides about this, but measure how we can create a new applications on new embedded chip and embedded devices as well. So what is IoT? So IoT, as we know that it is a embedded means a small tiny device which can help to provide the connectivity to the small embedded device for the global access from anywhere. The people can access those technologies as well. So what we call that IoT technologies are the programmed to perform action, okay, so to perform action to in a given manner where input receives from the embedded sensors to provide desired result. It means that we are collecting data from the small sensors, from the machine, from the patient's body, like that, and then those data can action taken from the using the smartphone or desktop computer for the further action as well. So this is the main goal for IoT technology. Means we are going to connect everywhere internet. Once internet is connected, so we can collect data. The main aspects why we are using the IoT internet, because we are collecting the data from the place. Okay, so that kind of the things we wanted to use. Maybe you heard several applications, like one application was very famous for IoT, like the toasters. We connected the internet there, and before the person's going from office to home, he just put it the bread, and automatically bread will be toaster will be on, and then he get the heat up bread, and after that come back home and he can have the dinner or breakfast, whatever he want to do. So remotely he can access to the toasters when starting time when this technology got introduced. And also we say that why we do this kind of things, to make things belong to the internet, and also we want to communicate remotely to these tiny devices. That is the main purpose of the IoT. What we try to do, we try to connect the small things with the help of internet. Okay, so for example, I am sitting here, and if you want to know the this chair information, so if suppose some technology IoT device is connected here, or the camera has internet in my room, so you guys can access camera and get to know exactly I am sitting in my chair or not for before delivering my talk. So you can react based on that. So you can see this kind of things in future, they are expecting to go for that. And also we say that it is the communication technology, and also it is a machine to machine communication. The before IoT terms come up, like two machines can communicate their information and make the actions based on that. So it's similar like C language is transformed to the C++, kind of. C is the procedural language, as you know that, and C++ is object oriented. So same thing, IoT is also object oriented, right? So internet technology, internet we provide the smartphone or the CPU, and after internet coming to the our device, we can access several things, right? But in the respect of IoT technology, IoT means things, right? So specific things we are collecting there. So this is same like object oriented. So that is the difference between internet and internet of things, like that. Okay. So a system that would be able to intentionally means at once somebody is giving the input and then they have to get the output. Okay. So this kind of reaction, we need to develop the smart technology for that. So it means that we have to create the platform where the somebody getting, or we are collecting sensors data, and after collecting sensor data, the system has to make the action. That is the part of the IoT. So in this diagram, you can see there is the M is machines, and there are trillions of machines or devices which we have to connect to each other to get the information. That is the main purpose of that. And another definition, uh, this definition is saying dynamic global networks infrastructure. It means IoT is a dynamic global network infrastructure, okay, with self-configure capabilities based on standard interoperability. Standard interoperability means the the communication medium. We have to create the standard protocol, right? So now maybe you heard about that. There are so many communication mediums like 5G network. We are a cellular network we are using. There are the Bluetooth network, right? So Bluetooth has limited range. Cellular network has the cellular, like we need a smartphone and SIM card to connect the internet or connect the data like that. So we have similar so many communication medium standard protocol. Okay, so which application, which standard communication medium we are going to select, that will be, we have to the application. I will talk more detail about that later on. So what kind of communication protocols going to be considered, what kind of interoperability means compatibility for the embedded device with the communication need to select on that, and where the physical and virtual things can connect. And also it must have, IoT have two identities, physical attributes, okay, and virtual personalities use intelligent interface. Okay, so it means if we are connecting the places, so the gateway or they can get to know how much data and what kind of information we need it to make the actions on that. So we have to think about that. For that we need seamless integration and the information network as well. This is the history about the IoT technologies. So you can think about the when the in 1930 first they invented the telegraph. So because everything communicating between the network, right? Communicate the information transferring with the networks. But IoT World Coin in 2008 around that. It actually 2001 it was coined the IoT terms, but properly people get to know that it's just to do boom when smartphone come up. When PDA was there, before smartphone there was the PDA. So when PDA device was there, then people start connecting their device with the tiny embedded devices as well. So so you can see that this is the just history, how the evaluations come up. Then machine to machine communication application. Then Tesla, they use it for their IoT devices. You can see this one is the much better. So 1982, the CMU, Carnegie Mellon researchers, they connected vending machines to the internet, remotely check their cold soda. It means that they have connected internet technologies to the vending machine to check it out. The vending machine has cold soda or not, or cold water or not. This kind of system they have connected 1982. So as you know that time when they connected the hardware device with the internet, from there IoT terms come up, right? But at that time they were not talking about the IoT. They were that world coins after about 30 years later, you can see, because 2008 the terms here you can see 1991 Kevin Austin has said about the Internet of Things was coined by Kevin Austin when 1999. So at that time they were using the technologies similar kind of that, right? Like World Wide Web, when it internet come up, so many things we are accessing from the global platform. But when these terms come up and then smartphone people start using on that, then they think about that, how now why not we can collect information using the smartphone. Then after they started first establish the communication embedded devices, like sensor network was the big research, because sensors was connecting several applications, several tiny things, right? So to collect information, and then sensors was after connecting the tiny things, it was wired or wirelessly connected with the gateway, okay, and then gateway was connected with the internet. That was the initial stage. Internet was working, IoT terms was working. Later the scientists and researchers decided for that kind of communication, we need to invest a lots of money. So why not? We can connect a small tiny device, the internet, so people can globally access that tiny device. Because once we are globally accessing that tiny device, it means that we are not relying on any other device. So we are making more secure network. That is the main purpose of why they started thinking about the IoT terms. This was the main reason. So you can see here the 90s, and then 2000 the LG introduced the first smart fridge. Okay, and then 2004 the first smart watch was introduced. Okay, and 2009 7 they introduced the Apple and smart iPhone wearable Fitbit, right? That Fitbit was useful for the your health, how much you are running, and those health related. And then based on that, and Google started car, like Google started testing their car for the self-drive cars, and smart TV got introduced in 2011. Then 13 was the Google Lens glasses come up in the market, and 14 was the EcoCos, the surgery smart home market, and then autonomous vehicle, semi-autonomous vehicles as well to connect the internet over the vehicles as well. So you can see the a lots of IoT technologies got introduced. But if you see here, all of them, all standard technologies was based on the cellular networks, like internet technologies from the smartphone. Okay, so they are using 5G network. Previously was the 4G network. Now those technologies based on the 5G network on that. So before going to the this kind of our new device to build up new technology, I'm going to introduce about the motivation. Like you can see here, in 1918, this was the home motor machine. I show you these slides previous as well. So this was the big size, can see, and to make the sewing machine. Okay, to sewing machine was using big motor to perform the clothes, to sewing the clothes like that. But today this is the toothbrush. Now small motors are connected here, so you can see how much evaluation has happened last 100 years. Similar, you can see the this kind of deserts area to grow green grass. Okay, to grow green grass in this area, we must need oxygen, mud, and water, but it is not possible the proper in this rate area. So what we do that we use internet and virtual internet. We can create the green environment in this area, and we can have a party and we can see the green environment. We can enjoy like that. So this is the just motivational things. You can see how much technology got changes last several years as well. So we have to develop similar kind of things as well. So before going to develop, we must have to analyze it. The useful that this kind of technology, is it benefit for the society or the community, and why we are working on this kind of technology. That is the another important question always people think. And how much money generated, is it going to be benefit for the society or going to be loss for the society, like that. So you can see here the total number of active devices connection in the worldwide. So here in 2015 to 2025, so you guys can see here the red color is showing IoT devices, and the dotted line is showing non-connected IoT devices, right? So it means that these are the also devices where we have to connect the internet. We need to make more connection in this part of that to generate the business, to generate the lots of money, as well as the devices and technology as well. So we have huge scope to develop this kind of technologies. Like today you can see we are in 2021 here, and then till 2025 growth is up to the more mark. That's why this kind of workshops are very, very important for the all students to develop the new technology and new business model as well. So before going that, so you can see here is the IoT. I have used this from the internet to just make you understand what kind of things we have. We are planning to connect with the internet technology. So you can see there is the smartwatch. in the smartwatch is useful for the heartbeats or heart rate monitoring and how much foot walk we are walking on that. So this kind of information is data is collected by the smartwatch, right? And then this smartwatch is collecting this kind of heart rate, heartbeats, steps counting, and then over the internet is transferring where the clouds. Okay, at the cloud has healthcare platform we call healthcare aggregate server. Okay, and now this my personal health, basic health constant things are regular basis they are collecting, like smartwatch is collecting and storing over the health care aggregate server. And healthcare aggregate server is associated with the my family doctor. So family doctors has some parameters. He has created the framework or platform. When he get to know that if my health or heartbeat has some problem, health condition has some problem, he will get the alarm. And then after he will guide us, we have to improve this kind of things or what kind of medicine we have to take it. So you can see that the small tiny device is connected from the my just watch, and that watch is associated with the platform like healthcare platform, and then platform is connected with the doctor, and doctor has to perform on that. So this is the one application, and still now so many mobile apps are available in the market. Smartwatch last 10 to 15 years working very nicely, and lots of people already using this kind of technology. Another application is the vehicle, right? So car, smart car, we connected to the internet, and once we connected the internet, so we get to know the locations, fuel, speed, how much it is. And if something is wrong on that, my previous talk I had talked about more detail what kind of applications we have generated based on the smart car solutions. So based on that, the platform will give the instruction to the drivers or the auto or the mechanic, and then based on that they can take action. Okay, so if there are some dangerous situation, the alarm or automatic message will generate to come up to the driver, or if vehicle has some problem, those kind of information transfer to the mechanic. So mechanic will send us message to visit their shop to fix that kind of problem. Okay, so you guys can see that everything are associated with the internet, and internet when it goes to the whole process is over the cloud server. Okay, so what we try to do that if we are going to give the more processing power over the tiny device, so we have to think about the battery challenges, we have to think about the computing power, we have to think about the data communication problem. Okay, so but once we are using raw data from the things or the from the application, and then after classifying things happening over the cloud, so we just have to use the secure cloud server. Okay, and raw data is collecting. Once data goes to the platform over the cloud, then they will be make the actions based on the after the performance or computing power to give the instructions on that. Similar things happening from the smart home, smart factory, and these all data you can see here can monitored by the tablet, mobile phone, or the computers as well. So this is the we can say the users monitoring aspect. So we are checking those information over the smartphone or tablet or computers as well. So these are the very basic infrastructure, what we can say that IoT technologies, and based on that we can perform for the development of these things as well. Okay, so there are the several parameters and several parts. Okay, so we will see here the current status. This is the one slides I copied from the internet, especially for you guys. For it's from the indiamart.com. Why I can corrected, because the cost of this test bed device is very less, and if you have interest to test to develop one technology, you guys can buy it this kit and then test it by yourself during this 1 week workshop period. So you can see here there are the three major parts. One is this one is the sensors, okay, and this one is the gateway. This one is the cloud server, okay, and this one is the users. Okay. So you can see here the sensors job, like for example, here is the temperature sensor or humidity test sensor. These are the very basic sensors. Almost every embedded device, this two things is already be inbuilt when you buy the embedded device. Okay. So, but as for the researchers or the making the technology, we have to test only the data, right? So the test data, it means we are collecting data. So what kind of data? Temperature data and humidity data. Okay, temperature data and humidity data. On here is the meters data. You can see electric meters, flow meters, like water supply, how much waters are flowing in the particular house. So those kind of metering is already available. And this one is the equipment for the generators or compressors. So these all things are the data generator we call. Okay, so this data, end of the day, what is the our aim is that we are collecting data. Okay, so we don't have to create in this workshop or in the IoT technology, we are not going to make the sensors. Okay, sensors already available in the market. You guys can buy the sensors. Okay, and once we buy the sensors, it comes with platform. That platform is depend, or you buy the sensor, you can use the breadboard to connect it there and then collect those kind of specific information as well. So this one is the data generator. One is the means this is the one end point, that is the main object on that. So this is the data generator. Second one is the gateway one. So gateway is similar, like the it is the gateway is the role is that which can compatible with the sensors platform, as well as their internet connectivity is available, because those sensors data we have to transfer to the cloud. Okay, so we must have to we must have to find the gateway or choose the gateway. Gateway is also available in the market, you don't have to buy it. So but you have to create the software. All right, so you have to make the protocols, what kind of communication protocols you are going to select it on this kind of device. So the gateway is the kind of dongle, and that can you can use it and connect over the CPU, because CPU perform like a cloud server for your test bed I'm talking about. If you want to test this kind of kits, so the dongle like gateway is connected with the CPU over the USB port. Okay, and then it has the all sensors data. You can use wireless or wired, it's your choice. But as IoT technology, so we always try to use wireless communication, because those sensors data is wirelessly connected with the those dongle or gateway. And the once data comes to the gateway in the CPU has the platform like cloud server. You are storing all data, and after storing those data, like it has internet, right? Or it doesn't have internet, then also you can use it, and this is the platform. So you can see here the database server, you are storing data. Now you are using the security authentication, you are using the platform, or we can say the middleware. Okay, so that middleware responsible is the what exactly information we need it. Let's assume that for healthcare application, for the healthcare application, we need every second data from the heartbeats data, right? Every milliseconds data collecting from the heartbeats. And then based on those data, we have to perform, we have to make the actions if some patients has in serious condition like that. But in the case of agriculture field, or in the case of where is not that much security involved, there is not cause for the life or death kind of things. So that data, we don't need every milliseconds data or every second data. We can generate a data from the 24 hours and then make the average, and then collecting from the 1 month's data to or 1 week data or 1 day data to make the actions for the water supply over the field, for the vegetation and crop, for transportation services kind of things. But in the healthcare doesn't work like that. We need every milliseconds data. So how we are going to decide these things? Who is going to decide information? We need a smart framework where we have to classify those data. Okay, so there are lots of machine learning and artificial intelligence tools nowadays. Recently, last 2-3 years, become very famous because they are trying to classify more advanced level those kind of information. Okay, so once we classify it, then only the related data, like we create this kind of network infrastructure technologies, but the platform has to make decision the results, the form of the results. So as you know, that data is collecting only 0101 form, right? Then after the making the analysis or classification, the like users cannot understand all 01 data. So what he has to do, that the middleware is the responsible to translate those data as a to make a genuine result form. Okay, so once we are working on our application like healthcare application, agriculture applications, so based on applications we decided what kind of platform and what kind of the data visualization we need it for that kind of. So you can see that this is the gateway, this one is the cloud server test bed. You are going to buy cloud server, you can use your computers, or you can, there are lots of free servers already available on the internet nowadays, so you can use on that. And the data visualization, let's create all the agriculture or healthcare data is start coming it, and then after performing over the cloud, you or your smartphone, you get only the related results on that. So this is the way how can have to work on that. So this is the very basic things which everybody has to know. So you guys can see there is the only major part in the IoT technologies. One is the data generating things. You don't have to generate, you don't have to create the sensors, you can buy it sensors. You can you don't have to make the gateway, you can have hardware kits, all hardwares are available. You have to just create the software for them to collect the information, to think which kind of applications you are going to use it for your IoT test bed for that. So you guys can see here, I just show you previous as well. The major components for the IoT technology is the device or sensors. Who is going to decide? You are going to select it. All right. So who is going to decide what kind of devices? Today I will just seek information about what kind of informations are coming on that. So these one by one, what kind of market, especially for the IoT technologies. Okay, so you can see and decide. There are the, so these are the major sensors. Okay, so the touch sensor, speed, position, motion, light, levels, these all sensors are available in the market. Okay, gas, color. So you can buy those kind of sensors to for think about your application. You can decide which kind of application you want to create it, what kind of services or technology you want to make it. Okay, so these all sensors are available. So you can think, and for these kind of sensors, these are the standard connectivity. Standard connectivity means, okay, so the communication, as I just mentioned that previous example here, look at here, this slide again. Here, the data is generated by the sensors, right? Now from these sensors, we have to decide how many range the sensors are. As I just mentioned that my body area network, body is the very small area, right? So we can connect sensors, very small range sensor, because their communication is within a meter, right? Within 1 meter. But if we are using sensors in the house, there are the 10 meters range. So we need to, the communication medium is at least 10 meters, right, to collect those kind of data. So same thing it is saying like that. So you can see here, less than 300 feet. So these kind of like devices like Zigbee, Wave, Okay, NFC, Wi-Fi, Bluetooth, they are performing the about 300 feet, and about 5 kilometer range we are using cellular network. Clear? What we are using cellular network like GSM SIM or CDMA SIM, or we can say that 3G, 4G or 5G. Okay, so this kind of we call cellular network. Cellular network, as you know, that BTS tower every 5 kilometers they have installed. Who has installed? Telecom company like Geo, or in India has Airtel, and I don't know, Vodafone. Those companies has their own the we call BTS tower. So you can see that at house or some places, top places, they have made the one tower. So we call base transmission station, BTS. Its name is BTS tower. We call, so where our mobile phone get internet. Okay, so that the BTS tower is the every five kilometer they have installed it, and how, and then wired all BTS tower are connected. You know that, right? So all BTS towers are connected from BTS tower to our mobile phone only wireless. So we are collecting data here from BTS tower to there. So that range is the within the 5 kilometers. And for the 100 kilometers, there are, you can see here, the LoRa WAN. Okay, so this is technology is, we have worked recently one research work based on LoRa technology for the traffic management or traffic monitoring system. Actually, LoRa technology has very low data, so means they cannot store big data. As you know that once device getting small, the data we cannot communicate with large, right? So that small device, small data communication because limited channels. Understand? It's like NB-IoT, okay, and then Sigfox. There is another one here like Zigbee with under the 300 feet. There is we also called 6LoWPAN. It's based on Zigbee device. So Internet of Things like IPv6 combined with Zigbee. That's why they didn't put it here. But we called 6LoWPAN. That is also very famous IoT communication protocols or communication connectivity device, which is used for the several IoT applications. So I will talk about that technology more detailed in later on. So these are the connectivity, and let me tell you, these all connectivity, whatever you are seeing here, these are the standard protocol. Standard means that decided by the community. Okay, maybe you heard name about IEEE, right? IEEE, you know that, right? So IEEE is a standard body. Okay, so they all over the world researchers work together. Then they found one technology, and then it's registered to this IEEE. Will when they satisfied it, then they make their tag. So that's why they called IEEE 802.15.4. That called Zigbee. Zigbee is from IEEE, and the LoRa, like LoRa WAN, this one, this is from ITF, Standard Technology, Internet Engineering Task Force. So these are the societies, they are responsible to create new technologies. So all over the world, scientists and the industry jointly work together. Okay, and they have every 3 months to 6 months meeting. Every all over the world, people go with their work and submit their work. All researchers evaluate it, then they start working on that. So then everybody got satisfied, then they make that the one standard technology. Once they satisfied it, then they make it called the RFC. Okay, so that is very important in the communication medium. Okay? So another one is the data processing, like all data aggregate, then data extraction, then data classification, and then data analysis. So I just mentioned that previously as well. Machine learning, a lots of algorithm tools are nowadays performing last several years to IoT data to classification case as well. Yes. Another one is the user interface. User interface, I just mentioned that desktop computer, smartphone or laptop are the user interface, or we can get the alarm. We can put here the one bell, and some action is happening in the house, like maybe happening, then automatically there is alarm on, right? So because the temperature is getting high, so automatically alarms started. So that is the alert signal as well. Notification message, I just talk about this one, is the my previous talk. When connected vehicle, if got accident, two vehicles got accident, okay, so the based on accident scenario, like how major accident happened, dashboard camera capture picture, okay, and then transfer to your family members, police station and hospital, the respective persons to whom this kind of things will be get to know that, or insurance company. So based on the accident, they can fix before getting late on that kind of scenario, right? So automatically message generated on that. So one is the user interface, is the notification, live trading, and remote control. Remote control means using the smartphone, you can on off that action as well. These are the user interface. Okay, so you can also decide which applications, which kind of user interface you can decide like that. So I have collected, there are the several major applications. So somebody is saying global military monitoring, G means global and S means smart. So you can understand, you can say somebody saying global connectivity means from all over the world, anybody can access from anywhere. Or smart means also, or intelligent means also same thing. So it automatically perform it, okay, before getting any major accident on that. So there are the several major applications like global healthcare monitoring system, global disaster monitoring system, global military monitoring system, agriculture, structure health monitoring system, logistics, and highways. Okay, so there are several applications. Okay, smart city, smart home, smart government. So you can see there we have so many applications. And let me tell you again, like for example, I'm deciding smart healthcare monitoring system. So now inside the smart healthcare, we have to make it intelligent, so many health related devices. All right, so for example, blood sugar monitoring device, for example, temperature monitoring device, nowadays is the COVID testing device. Automatically we can go there in front of the camera and they test it and our temperature and let us know without touching anything. So many applications devices. So you guys can make decision which applications, which field you are interesting to make your technology. Okay, once you make the your field, then go deep on that. What kind of work already have done, what kind of work and what kind of challenges people are facing, find out challenge and try to solve it, that challenge problem with your idea, with your algorithm, with your programming skill. Okay, that is the way how the students and researcher can perform. So now the emerging IoT technologies, the emerging IoT has the potential to build limitless, okay, leveraging for huge volume of accountable data or the actionable data. So those data can perform huge amounts of the data, right? So as I just mentioned that the sensors are collecting data every millisecond. Okay, so those every milliseconds data, it means we are getting to know each and every bit of information for specific things. So once we are getting to know each and specific informations for everything, okay, so we can make more better results for further, right? So we can make next version or next scenario much better version of that kind of problems or the solutions or what kind of impact going on that. We can make the more larger impact if we are getting to know everything about that, the devices or the entities or the things like that. So, and IoT will accelerate, like IoT technology is going to accelerate and increase the network agility and integration of IoT, like AI. Okay, so artificial intelligence things, once they integrate it, then we can make more performance on that. Artificial intelligence, why I'm mentioning here, all over the world recently, especially for last 3 to 4 years, people are started working artificial intelligence thing, because they, as I just mentioned, that sensors are collecting sensing data. Connectivity are those data has to transfer to the cloud, and once data has to cloud we must have to make the intelligent server. Artificial intelligence means they can sense those data and memorize it. They cannot make fault in the further applications. Their IoT has huge result and huge responsibility on that. Okay, so especially for the healthcare applications, as I just mentioned, that every bit of my data is going to healthcare aggregate server. My doctors are connected, my family doctors are connected with that information, health information with me. And and he knew that what kind of food I am eating, and I have allergy on that. So next time, if similar kind of the food I'm eating, so he's going to make us the, you have to avoid this kind of oily food, or you have to avoid this kind of low protein meal as well. So based on that, so before making the major disease, a major problem, we get to know on that. And this is the potential till IoT by 2025. The scientists, especially the McKinsey is the global research institute, they do the analysis all over the world, which field peoples are going to work to perform more business aspects as well as the economy aspects as well. So you can see here the factory, like smart factory is the major research topic. So especially there are the 1210 billions dollar investment, the money generated by the factories. But if we are going to connect IoT technologies by 2025, means in next 5 years, the amounts is going to be 3700 billions dollar. Okay, so you can see there is the several times, about 3 times more than the 2 times more than the money they are going to generate in next 5 years. Okay, so these kind of things are IoT because of the IoT technologies. Okay, how they are going to impact, as I just said, that they are going to learn perform more future, how they are going to get it in on that. So then work site, then smart city, the project going on, several projects going on this field, logistics and transportation, and healthcare as well. Okay, so these are the major top research opportunities where the several factories and researcher and scientists are working on that to produce a lots of the business model as well as the services as well. These are the devices, global number of the connected IoT devices. So you can see here as well, since 2015 to 2025 graph. So they are also showing the what kind of technologies and they are going to connect. For example, here you can see, okay, this red one is showing the low pan, like wireless network. Means, as I just said, that IoT is a tiny small device. Okay, let me show you one small device every time. Here is the one device. I have shown this device previous talk. This is the smart car. This device has a capability to collect vehicles data. Okay, small. It has the connectivity and the data is going to collect it from the vehicle, from this port. We called this called OBD, on-board diagnosis, and we collected this using this device from the vehicle data. Similar healthcare device, similar all smart factory device. We collected data, and after collecting data, we has to transfer to the cloud server. Now the size of the device is very small, right? So it means we have limited number of the battery for this tiny device and limited the capability of the communication power. So we use this device is the low pan, this red one. Okay. So IoT means the most of the devices based on the wireless personal area network, means so many small devices like in the house or in the offices. If I want to connect IoT, small, similar kind of around 25 to 50 devices for a specific purpose. I want to connect one device in my CPU. I want to connect one mic. I want to connect in my rack, which kind of books, one camera. Okay, one is the door lock. So these kind of things are going to connect it. And then, as you know that this kind of small tiny device, we don't need more expensive device. We just need wireless personal area network. Reason is that the cost is very less. Very less, when I said that, it means around 500 rupees, Indian rupees, and around $10, less than $10 cost. The devices are available. So you can see there are the cellular network, wired, wireless, and 5G network, and there are so many technologies. So you can see that which one global connectivity we are going to use. So as I just said that end of the day, sensors data has to use connectivity, right, to transfer data to the cloud server. So internet connectivity for that. So there are so many challenges and technologies going on. So many challenges for the internet connectivity, because still now not a standard technology decided. Several communication mediums has a standard protocol, but still now not generated. Which technology going to use for all things like that? So scalability, naming, and identification are the big challenge, especially for the locations case. So several researchers and community have served the service-oriented mechanism to deal with IoT challenges. So they have large heterogeneous devices and large heterogeneous data with the complexity. So we have to make the solutions for that. So let me show you. I was talking about the 6LoWPAN. Here is the technology. This is the 6LoWPAN kind of sensors device. They can communicate one to another device like that within a 10 to 25 meters. So those devices, I think something problem going on. Hello, can you see my screen?
No, sir. I think it is not visible now.
Okay. Let me go again. Automatically, I think disconnected. I don't know what the reason. Now it's okay, right?
Yeah, it's visible now.
Yes, sir. Yes, sir.
Perfect. Thank you. So we was here, right? So we was talking about the connecting devices here. So look at here. I was talking about the IEEE 802.15.4 that called the Zigbee, or we call low pan device. This name is low pan Zigbee, little bit difference, but almost same standard. So the standard comes from the IEEE 802.15.4. So here they wanted to connect the IPv6. Reason is that for the global access. So when we want to connect IPv6 protocol over the small tiny device, so you can see the size of the device is very small. So once we want to connect it here, it's impossible, right? Because this device size header, the every device and the technology has the size of the header format we call. The header format of this kind of device is 127 octets. So if I say that octets, it means the bytes as well. In the networking, we call octets, right? So 127 octets, and the 6LoWPAN, like IPv6 has 1028 octets. So how much, it is impossible to go with that tiny device. So what we do that, we compress IPv6, okay? Compress for just global access and global connectivity. For that is small embedded tiny devices for that. So once we compress it, then we use it for that kind of devices for global access. So this one is the, as I just mentioned, that the AI based side, like two machines, like the sensors are sensing data, transferring to the gateway, okay, or the cloud server. They don't understand what kind of information they are transferring to get the data, because the sensors only sensing and then transfer to the data. And then if we create the middleware platform, here the machines transfer their data to the middleware, and middleware has all history or story about the data as well, right? So then this middleware make the data to information, and this machine has to get the action based on the information. And same thing, this machine is transferring their data, and middleware will translate it, and this machine has to take the action. So these things is very small and basic things, and how much intelligent middleware or semantic web we create it, that much useful for our applications data as well. All right. So this is very important factor here. The middleware is that recently, as I just mentioned, that AI teams like artificial intelligence or machine learning algorithms, we can use it here to perform data. So you can see this kind of computing power, the users has to make decision where we want to connect. We want to this computing things over the machine. It's impossible, right? As because the machine size is very small, tiny. So better is that just sensing data come to the gateway, and gateway has the big power, big computing things, so they can perform over the gateway or from gateway to transfer over the cloud. So it depends where we want to perform computing power. All right. For example, some of the cases we use our mobile app, we create the platform. So once data comes to the our smartphone, then it will give us the after the computing, give us the exact information, what kind of information we want to perform here. All right. So depends where you want to use this kind of stacks as well. This one is the one framework stack I just mentioned before that. So this is the stack. This stack, if you see this one, then come to here. So this is the 6LoWPAN stack. 6LoWPAN means IPv6 low power wireless personal area network. Okay. And another one, this is the alpha routing protocol. So how routing protocols perform over the 6LoWPAN, this is the whole process. But let's go to the stack first. This one is the TCP/IP stack. You can see here, everybody has studied the OSI layers and TCP/IP net layers, right? So you know how internet perform based on the TCP/IP. Physical, this is the MAC layer, means data link layer. Then this is the data link layer. We use here the MAC, and this is the AL, means adaptation layer. Okay, and it is also called network layer in the TCP/IP. This is the transport layer, and this one is the application layer. So once we use the 6LoWPAN, we make it like this kind of protocol. And here we use cross layering. And once we use it, here is the security for that. And we use here the gateway. Over the gateway, there was the adaptation identifier, we called ATT. So adaptation identifier is responsible for all 6LoWPAN 10 devices, and then translate over the stacks here. So let me show you the how it works. Okay, this one is the alpha autonomous load balancing for the routing protocols. I think just for your introduction, I'm just showing this one, but I'm not going more details how it is going. But you can see there is the data monitoring module, source learning, and then it perform whole routing concept to perform the action. This is the process. And this one is the global connectivity. Just I mentioned that how we compress it, that is the more important, right? That maybe the questions come up. The professor, how come you have compressed IPv6 for the low power wireless personal area network like 8015.4? So you can see here the 40 bytes IPv6 to byte the 5 bits adaptation identifier replaced. Where is the 8015.4 is the in node. Okay, so the first RFC was the 6280. They have discussed about the header compression techniques. So how these things, routing things perform, the professor from Jaipur, he is going to more details, whole things, but I'm giving you just basic overview today. So the basic overview is that IPv6 address compression during the global connectivity we use for the short AID. We call adaptation identifier. So you can see over the gateway here. So adaptation identifier using the translation table. Okay, so this is the several 6LoWPAN devices. So many devices being built here, and 6LoWPAN devices infrastructure or the network, and we use these devices for the hospitals. So because we tested this whole concept over the smart hospital monitoring system, so we built these devices in the hospital and then connected with the patient's body, all devices, to collect patient's data. So means doctor does in the hospital, doctor doesn't have to go and check each, and nurse or doctor doesn't have to go check the every morning or health condition, basic health condition of the patients. So the technology automatically collecting data and transferring those data to the cloud server or the base station where person get to know those kind of information. And outside is using with the IPv6 network. So they use adaptation. So more detail on that. This is the same stacks. So here you can see here what we did, that adaptation layer, we use the AAD, adaptation identifier layer, where adaptation identifier is more responsible for the IPv6 network to the this stacks. Okay, so this we generated in our laboratory and tested. This is the testbed result. So these all are the 6LoWPAN devices. Okay, so we install these devices in the hospital, and then after all sensors data goes to here and get to know remotely what's going on in which room, how many patients, what is the patient's data on that, we get to know on that. So real-time testbed connectivity. And this slide is showing the routing communication technologies. These communication technologies are useful for the connectivity. Okay, so if you guys see here, this is the topology. Okay, what kind of topologies, which applications going on performing, you know the topology means, right? Peer-to-peer, star topology, right? Mesh topology. So these kind of topologies, which is going to perform. Power, how much power we need it. This is the speed of the data communication. All right. So the speed of the data communication means this is the standard technology. These technologies are used by the IoT technologies as well. So I just mentioned before which applications, which communication medium we are going to select it based on these technologies. Okay, because each one has their characteristics. Applications are here given, cost given, range, how many range it's performing, speed, the data communication speeds are also showing here, the power, low power, high power technologies they are performing, and network like personal area network, local area network, right, wide area network, where those kind of things are going to work on that. So based on the communication and application, we select it for that. And after selection, we can decide which applications are more suitable for that. So this is the just standard IoT technologies like Bluetooth Smart, and this one. These are the just for your introduction. More famous one. What I just wanted to. So we talk about the 6LoWPAN devices like that. Okay. So I'm going to show you one very quick application. Like we are running out of time as well, and I just finished. I think less than half slides. Okay, so IoT technologies, there are about 50,000 millions things on the earth, and 50 to 70 billions machines, all types, and which are less than 1% today is connected. So we have huge scope to make the all things are connected. And this one I saw you previously as well. And keep in mind here always, this is the hardware technology. We can select based on the application like connectivity, embedded processing unit, and sensing unit. So the sensing unit, embedded processing unit, and connectivity here 6LoWPAN. So we can, these are the hardware things. Okay, it's available in the market. Okay, and application we are going to decide where we using this hardware. And red one is the software. So we must have to focus from here to here how we can build the framework, how we can build the our algorithm to create the particular application. That is the our role, our all researchers' job. So we have to make it on that. Or somebody want to make it modification and combining these applications. If here VLSI design class student, somebody want to make some specific hardware for a specific application, that would be also lots of opportunity. Okay. This is the global healthcare. Let me go very fast. The healthcare applications. The global healthcare monitoring system is the protect and improve the people's health and well-beings, as well as reduce the health inequalities in the country or in the society as well. So support people across the globe rather than the concern of the particular nations to recognize the health issue. And also global healthcare monitoring architecture is very much complex, which is going to combine combination of the ICT technology, information communication, and biomedical technologies to come up to the public health solution. And before going that, we must have to observe public health is responsible during the disaster case. Like maybe you heard about that few years back in the Nepal has heavy disasters, right? And there was the lots of connectivity problem. Doctors cannot visit in that area. Okay, so in that case, if we have a technology, healthcare, this kind of technology, so people's remotely all over the world, people wanted to help them. So if we have a technology, we distribute them and remotely using the telemedicine, we can concern and provide them solutions on that. So IoT technology is very much useful in that kind of situations as well. And to support public health, like low and middle incomes country, like all IoT device cost are very less. So as you know that to visit hospital from the remote area, it's very, very expensive. If we have the IoT devices each person's house, so they can basic information, they get to know and communicate using the telemedicine services with the doctors and hospital as well. So here is also very much important for that kind of solutions. To support health and well-being, like we need the all communication and non-communication devices as well. So these kind of things are very much useful to support on that also. To address global healthcare requirements like more deeply, IoT and biomedical, as you know that biomedicals are making biomedical sensors, biomedical technology. And we have recently we started few years back one department, biomedical departments. That departments are creating several embedded and IoT technology, IoT equipments, and making combination with the computers and electronics departments to produce the solutions on that. All right. So these departments are very much useful for the healthcare applications as well. This is just very basic information like sensors for a smartphone, like internal sensors and external sensors. This one is the wired sensor using you can see this is the smartphone and we use it here using the USB port, and this is the wireless sensor. So wireless sensor means the data directly comes to the smartphone, and wired we have to use this type of dongle to collect information. These are the challenges. And smart and intelligent sensors for health care system. So I'm going, this is just difference between what is the smart sensor and what is the intelligent sensor. So a smart sensor is the combination of biomedical sensors, sensing elements, and analog interface circuits, and analog to digital converter ADC, and bus interface in one housing related to the technology aspects. But intelligence sensor is also is a biomedical sensors which has one or several intelligent functions such as self-testing, self-identification, self-validation. Maybe you remember that smartwatch, right? So smartwatch, what they are trying to do that, smartwatch was sensing those information and transferring to the cloud, right? And then based on those data, we can get to know over the class, from the concern with the doctors. And intelligence sensors, they are using over the smartphone, giving us instruction. directly at the same aspects on that. Now, a 6LoWPAN device based one application, let me show you very quickly. This is the adaptation layer I just showed you before. This is the TCP IP protocol. Okay, and this one is the gateway. So over the gateway, as I just mentioned, that if we are using for particular application, so this place adaptation layer, and this one is the MAC layer, like Ethernet MAC layer here. So 8015.4 MAC layer, we use here modification. Why we need this modification? Because we need from 6LoWPAN device to connect with the gateway, right? And this much is also using for the TCP IP stacks, because the end side we are using IPv6 network, and this side we are using 6LoWPAN network. So if we are using 6LoWPAN network, so to connect with the internet, we must have to use the to change the gateway as well. How to change? To change over the this two stacks protocol. Okay, how to change this? As I just mentioned before, communication connectivity protocol. So connectivity protocol, you can do modification for your healthcare. Now, question here is coming. This is the most important slide. So from here, you can understand the portion, as I just mentioned, that the header format 127 octets, right? 8015.4. So now this we need it MAC UDP protocol, we need for 4 bytes. Now payload here, they are recommending 108. But once we are using for the 64 bits over the, for the IPv6, they are considering 40 bytes here, right? And UDP, yeah, they are using for 8 bytes here. Now for we have 53 payload, we call means application. Keep in mind the healthcare data here. We are collecting data. How much data we are transferring from patient's body to the cloud server or to the gateway. So we have to play with this header format. Okay, so we can decide how much we are going for the medical data, how much we are going for the security purpose. If we want to more secure, we can use some bytes here for the security. How much byte? Based on the security protocol. All right, so we can decide it here. The once we decide it, then it becomes more low, right? For example, you can see in this case, low PAN security we have considered here. For low PAN header, only 1 byte, but once we consider here security, that use 20 bytes more. So now healthcare application, we got 33 bytes. Now you can see that within the 33 bytes, how much information, the frame format, what kind of information we need, we can collect from the patient's body. Very basic information, temperature, ECG, PPG, this kind of information, right? We cannot collect big healthcare information data. So this kind of you can decide it and then make the protocols for the another so many parameters for security protocols. Much is the how we have tested. We use here biomedical sensors. One is the 6LoWPAN device. These are the wireless communication. So we use here star protocol to establish the communication. Okay. So we called the balancing between the biomedical sensors like body area network. Okay. And then from this 6LoWPAN to gateway, this kind of communication. So first we have simulated over the NS2 network communication protocols. This kind of, first we test our algorithm. Okay, and then when patient move here to another region, one region to another region, then how it is performed. These are the changing and protocols. So if you want to know more details about that, we have research paper. So where I have explained everything in detail, the all algorithm based on that. This is the algorithm where a personal area network move from one area to another area. So we use it for the patient's mobility. So these solutions, when they move from one place to another one, you guys also can think this kind of mobility when means we wanted to not fix patient in the bed, freely move inside the hospital area as well. And their data is continuously transferred to the cloud. That is the main purpose of this stacks and this protocol. Like this kind of area. So you can see here in the hospital area and patients are moving. So there are the signals coming, like good signal, bad signal. So for example, this, if patients are here and gateway are here, so from here to here, when they're moving, so they know that bad signal, so they get to know why it was the bad signal, because of the patients was moving in the out of range network. When it is in the limited range, so we test process these kind of devices to test the protocols. This is the real time test bed. Patients was moving and what kind of data they are connecting. So this device is available in the market, 6 low pan devices. So basic for the testing our protocol, like software, right? And they provide this kind of simulators. So humidity, temperature, light, flux, this kind of basic protocols. Sensor we test data, real-time sensors data collecting from that. And the display cases, we get this in the numbers point. So this data is hard to understand for the doctors and anybody, but they can give the digital numbers here, uh, in the just numeric numbers, to what, how much temperature it is, how much blood pressure, ECG, PPG temperature, the basic data. We have the variable test bed. So this is the one of our lab member. So here he has used the belt. Okay. So for to collect the ECG data, that is the called biomedical sensor. Now he is running over the treadmill. The challenge was that if you are wearing the healthcare data or healthcare device, that is no problem. Healthcare device, if you are wearing and sitting properly, very nice data is coming. But once you are walking, running, and sleeping in wrong direction, okay, so that is the more challenging task. So during our research work, we have to test all the parameters. We have to perform this kind of information. So these are the real time ECG. Patient have to go and test everybody. They sense it and transfer over the cloud. So the technology very much useful for that. This kind of device also very much useful for the military purpose. The persons or the soldier who are living very high temperature and low temperature weather, so they can sense and then send the information to the their base station, and then they can make the action based on that, right? So this is the device, the ECG device. So they are collecting data real time, okay, from the patient's body. Full test bed, the results. So this one is the result. Once pink one is the one's moving. All arrow is showing the movement, okay, and another one is the static patient. Then we can see how the multi-hop protocols are working here, right? The range are getting up. So this is the base station, suppose gateway, blue one, and this pink one, the arrow one is the moving. So once they are moving out of the range, so they can transfer their data to nearby their patient, and then this goes to that. So we tested our multi-hopping connectivity as well for that. So this is the healthcare applications data. And this one is the 6-LoWPAN all devices, showing that IPv6 for connectivity devices, this much showing on that. It's just running data for that. And global diabetes, I think this is the time. I think we have talked. It's time done, right? That time. So there are the
Yes, sir. Yeah,
yes.
you can take 10 more minutes, sir, because we are having next session from 3:45. So if you wish,
So
you
it's
can
better.
continue
So
for
because
10 more minutes.
I think it's better to let's discuss and ask audience two more questions. I'm going to just conclude it
Sure,
very quickly.
sure.
Because if I'm talking, so it's I'm not getting how much they are get understanding or not. Anyway, so this one is diabetes, similar kind of technologies to connect the patients. Next time, when I have chance, so I will talk more that. So this 6 low, so we published this book. All information, test bed, real time implementation is mentioned in this book. So that book name is Future Internet Services for E-Healthcare Monitoring Applications, which called IPv6 over low power wireless ad hoc sensor network simulation and test bed result. which was the latest technology. I published this book in 2011, so it's about 10 years old book, where 6 low time. First IoT devices for healthcare applications at that time. So this is current project going on. So they're untagged one. Yes, let me give you more quick introduction. So there are the more challenging things. These challenging things means still now lots of opportunity to develop software. Okay, so the software for the big data analysis. Okay, self configurations still huge scopes, and AI compatibility things are the lots of opportunity. If you have interest, you can work in AI compatibility protocols. You can develop it on that. Still now no standard things, so you can try to work standard body. How to work? I just mentioned before. IEEE in 802. Every 3 to 4 months they have meeting. You can choose any topics, make some new correction in their previous work, and join and submit your work. If your work is acceptable, so they will invite you to present your work as well. Unique identification means still now IoT device has the mobility problem, so we need unique identity. Once device move one area to another area, like one country to another country, care, connected vehicle, smart factory, okay, smart home, smart city. So you can, and business also get, and economics, government. Very much. If you have any questions, please on your mic and ask me directly.
Yes, sir. In chat box, we can see one
Yes, please
question
ask.
asked by our student Anjali, and that is a definite question in the mind of many of our students. That he asked that what opportunities as students to work on projects under the guidance of your institution. So she might be looking for any internship opportunity, something like that, if whether it is feasible or not, or
Yes,
any guidance.
it is feasible, and every year I invite several students from India, especially, to our lab. And last year we invited about 4 students with 4 different universities, and they work here with our team and they perform for IoT made. Let me explain you. So similar, one of the student was working on the blockchain technology. So are interested to work on that. Let me show you very quickly here. This is the one company which I'm the founder of. One, read it, this white paper, and if you have interest to work in this project, we can work on that. Another one we are working, it is the India company I started last year. So this is the smart city project. So still now we are working 2 projects in under this company in India. One is the smart transportation solutions for traffic management system. Another one is the healthcare applications. So healthcare applications, the project I just discussed before, we have implemented. Now I'm transforming the technology from Korea to India business opportunity. So if you guys are interested to work in this kind of project, please read it from here, and you can search on my webpage as well. So any project, if you are interested, just drop me email. Then we can talk more on that.
Yes, sir. One more question is there from a participant named Shamir Chetri. He asked that with smart home devices entering people's lives, what are your views regarding privacy since most of the smart home devices work on microphone?
Yes, very good question. Uh, Let me tell you again. Once we are working on the technologies, we have to depend some kind of the reliability, kind of the security steps. For example, if you are working talking about the smart home is the persons get to know only the home related networking, right? So then that kind of they have to think about the security which plays market nowadays, and especially the blockchain technology. We are working blockchain, so that blockchain is the very high secure that provides very high security for the embedded device as well. So it depends which kind of security or which kind of solutions you are looking for that. As I just mentioned that for the light, as like smart home, tube light, refrigerator, we don't need this kind of smart homes devices to make secure network, right? because the access by the family members, not outside person. Because outside persons want to access our home device appliances, he has to come with the gateway which is already secure. Is it right?
Yes, sir. Yeah. We are having one more question from Dr. Tashir Ali Sheikh, and he asked that he has completed recently his PhD opportunity, if it is available in your guidance, in your institution, under your guidance, and he is interested on IoT topics related to medical applications.
So, okay, thank you very much, Tasir. I'm looking one postdoc candidate, and just drop me email. Okay, you can find my email IDs here, and send me your CV here. Okay, once you send me, I will reply back to you by tomorrow.
Yeah.
Okay, sir. Okay.
So thank you, sir,